Good morning.
Good morning, sir.
Can you all hear me? Whether I'm audible to everyone?
Yes, sir.
Okay. Right. Still people are joining. Any questions from what we have learned on previous day? Any questions from what we have learned earlier? Right. If not, we can continue. So we have basically said the factorial experiment. In the factorial experiment, we have factors defined. Those are categorical variable, and also we have levels. Suppose, let's say, if you have one factor, factor A, you have you can have any levels, but we are taking example with 2 levels. You can have any number of levels. And you have factor B. Again, you have 2 levels, B0 and B1. Right? So that these are the factors basically and the levels. So we want to see the main purpose of this factorial experiment is to investigate the interactions. Right? Last time we talked about what is interaction, the different response of the different factors to the different levels of different factors. So that is basically called as the interaction. So that the interaction, today we will talk a little more on this interaction. Further, we can classify this interaction into different levels of interaction. And meantime, the other advantage of this factorial experiment, estimations are more precise. Why estimations are more precise? Because there are indirect replicate. We will see that today or in the meantime. What do you mean by indirect replicate? Right? So due to this, people prefer, and also we can combine experiment. That doesn't mean we can combine all kind of experiments. As I pointed yesterday, we can combine some of the experiments. We are trying 2 VD sites with the same variety, 2 varieties, V1, V2. We can try those 2 varieties for individual VD sites separately. That is one way. The other way is we can combine. Right? So that is, we said, we decide spacing with variety, for example. Right? We can combine. So that is the advantage of all these factorial experiments. And also, we said if you have, let's say, variety 1, variety 2, if you have we decide 1, we decide 2, this is the response. Usually we measure the yield of paddy or whatever it is, paddy or any crop. So here you see the response for these 2 varieties by these 2 we decide. It's more or less similar way of response. If the similar way of response occurs, then we call it as no interaction. So this kind of diagram is called as profile map. Actually, have you all started learning little on SPSS? Have you started learning on SPSS?
Yes, sir.
So here in the SPSS, we can request for this kind of map. This is called as profile map. Directly, it's a SPSS is a menu-driven software. So you can simply request to give me the profile map. You will have to specify the variables or the factors, then it will give automatically. But in SAS, you will have to give the commands. SAS is a program where you will have to write the commands. You have to type some of the commands. That is very difficult to remember. Not easy to handle SAS, but it is more versatile. But SPSS is a more friendly user. User-friendly. It is user-friendly, so that we can do it very easy. If you want, maybe in the practical class, I will show you if necessary. Right. So that is the aspect of interaction. Suppose if the response, as we said, if the response is different, let's say we have variety 1, variety 2. If the response is different, so here V1, let's say V2, whatever it is, right? Here the responses are here. So what we could say for V1 variety, variety 1, W2 is the better option. Similarly, for variety 2, W1 or the V decide 1 is the better option. In the earlier case, for both varieties, V1, we have V2, W2 is the good V decide or the performing V decide. For the variety 2, the same V decide performing with a similar condition, right? So that is the situation that we have already covered last time, right? Now further, I want to talk about this interaction a little further. Last time we have just, I have just shown you how to calculate the main effects, and we also said what are the conditions for main effects, right? So main effects, how we can calculate the main effects that we have seen. Average of lower levels minus the average of high level. Suppose if you have 2-factor factorial, let's say 2-factor factorial, right? So A and B are the 2 factors, so that we could say A and B are the 2 factors, which is called as main effects. Then the combination of these 2 factors, which is called as interaction. And also we have said that if you have 3 factors, A, B, C, then we have A, B, C as the main effects, and AB, AC, BC as the interaction, but it is called as 2-way interaction, and ABC is called as higher order interaction or 3-way interaction. We have seen all these like this last time. If you have 4-factor, you should be able to write. 5-factor, you should be able to write. Right, now coming back to the effects. the main effects, we can calculate between the levels. If you have 2 levels, it's easy. If you have 3 levels, we are seeing the difference between all the levels, right? Right. So we calculated the main effects of first variable, x1 variable, or the first variable. Okay. Then we calculate the main effect of second variable. So this is the main effect of first variable. Any questions on that? So we will come up with the effect of the first variable, which is called as main effect. So main effect of x1. So here we are considering this is A and this is B, x1 and x2, 2 factors. Okay. So we simply take, if you want to get the effect of A, we take the average value of pluses, the difference between the average value of pluses and the average value of minuses, if you take the effect of A. Similarly, if you take the effect of B, again, we take the average value of pluses. So you see, this is the average value of pluses and the average value of minuses, right? That is the average value of minuses for the second factor. So we take the average of, look at the difference. So that is the main effect. So this is not the end point. This is just for the calculation, just getting the concept. We want to see later on whether these values are significant or not. That is a different story. But this is just for your calculation, right? So that is for the main effect. The interaction effect I have shown you last time. You cross multiply and see what are the positive signs, what are the negative signs. So take the difference between the positive signs and the negative signs. Okay. Right. Now, further talking about profile map or the graphical explanation of the profile map or graphical interpretation of the profile map. Usually, to see the main effects, whether the main effects are significant or not, right? Look at here, we have already said variety 1, variety 2. I said this is, we decide 2, let's say. We decide 1. These are response. Now, tell me, look at this example. I'm just showing the example of main effects. So tell me, what is the average of V1? Tell me what is the average of V1? Average of V1, this is the response, right? Average of V1 is average of these 2 points. Average of W1 and W2 when variety is V1. That is the average of that. This is the average of variety 2. If you connect these 2 lines, right? If you connect these 2 lines, right? Draw it very carefully. If you connect these 2 lines, if that line is similar to this condition, so that means it is parallel to the x-axis, basically, then we can conclude that there is no any main effect. We are talking about main effect, not interaction. We say here we have interaction. Interaction is present, but what is the average of main effect of variety? Not present, because the average is parallel to the x-axis. Average line is parallel to the x-axis. So that we could call it as there is no main effect of variety, right? No main effects of variety, right? So what is the average between here? Very difficult to get the response of the average between W1 and W2. What is the response between W1 and W2? I will use another color. What is the response between W1 and W2? Average of W1 and W2. What is the average of W1? It is somewhere there. I don't know, maybe somewhere there. The average of W2, again, it is somewhere there. So the main effect of V-decide also not present. Actually, this situation we call it as masking, but don't worry about that. So here, no main effects, but there's an interaction. Look at another example. I mean, here, if the line is parallel, no main effects. If the line is slant, there's a slope, we can call it as there's an effect. So just explaining. Look at this. I will take some time for drawing. As an example, huh? Right, now look at this. These are the response. I will explain only one, right? So this is response. This is variety. Let's say we decide 1, we decide 2. Right. Now let's say variety, we decide, variety into we decide. So this is main effect, this is interaction. Can Dilhani tell me whether there's an effect of variety, main effect? Dahanayaka, Dilhani Dahanayaka. කියන්න බලමු main effect variety වල effect එකක් තියෙනවා. Anyone? Nishani?
Yes, sir.
Yeah. Is that Nishani?
Yes, sir.
Yeah. කියන්න බලමු variety වල variety කියන්නේ main effect එකක්නේ. Main effect එකක් තියෙනවද කියලා අපිට කියන්න පුළුවන්ද මේක දැකපු. Can we say whether there's a main effect of variety?
Slope line.
Huh? What do you think? මොනවද හිතන්නේ? What is the average of V1? Average of V1 is this. What is the average of W? Sorry, average of V2. What is the average of V2?
Center of the V1 and
ඒක ඇන්දනම් පැරලල්ද නැත්තම් ස්ලෝප් එකක් තියෙනවා.
not parallel. Have slope.
Yeah, there's a slope. You see the average of V1. So that there's a
Main effect.
slope. So we could say there's a effect of parity. That is how we find. Now tell me, what is the average of W1 and W2? I'll use a different color. What is the average of W1 and W2? Madhusha, Pusparaja. Average of W1 and W2. Pusparaja, are you there? Madhusha.
It's between the V1 and V2.
Between?
V1 and V2.
No, I'm asking the average of W1 and W2. What is the value for W1 and W2? This is the first value. Let's say W1, this is the second value. What is the average of that? You will have the value somewhere there. Right? Average value. What is the average value of W2? You have the value somewhere there. So if you draw the line, definitely it's not parallel. Is it parallel to x-axis?
No, sir.
No. So that there is a significant effect of weed also in the main effect. The main effect, there's a significant effect. That is how you find out the effects, by looking at the profile map. So these are called as profile map, right? So this is called as profile map. Right, now tell me whether the interaction is significant. Peony?
Yes, sir.
ඉන්නවනම් කතා කරන්න.
Yes, sir.
ඔව් කියන්න බලමු. interaction effect එකක් තියෙනවද නැද්ද කියලා. ඒකට කොහොමද average එක බලන්නේ?
There is an interaction.
There is an interaction, because if you look at the way of these two lines, these blue color lines, two blue color lines are not parallel. They have deviating. They are not parallel. They are deviating. So that we could say there's an interaction. So you see, all the effects are present in this case. In the early case, I showed you only one effect is there. Right? In the earlier case, you had only one effect. Here we have only two factors, variety and we decide, as an example. Right? So you see, different scenarios are there. Now I'm going to show you different scenarios of these interactions and the main effects. Right? Can you all see the slide?
Yes.
Right. Now you see, I'm just plotting to main effects, only main effects. The main effect averages. Can you remember? We said if we want to find out the main effects, you see, main effects is if it is parallel to x-axis, no main effects. Is it parallel? For example, here. Here we are finding out values for average of levels of x1. So here, sorry, x2. Here we are looking at the values for x2, right? x2. So that here, if you can mark it here. So these average of these two, the difference between the average of these two and the average of these two, pluses and the minus, right? Averages of pluses and the minus. So we know average of 14 and 5 is 9.5, right? Average of 8 and 3 is 5.5. So you see there's an effect. There's a main effect. We can find out. Even without calculation, we can say there's a main effect of x2. So similarly, we can find out the main effect for x1. Right, now coming back to interaction. Just to get to know about interaction, I have already mentioned about the interaction concept. So in the interaction effect, we say if there's a parallel, you see, if there's a parallel, we say no interaction effect. If there is a crossover, parallel mean these two lines never cross over, isn't it? If there's a two parallel line, is there a chance these two lines to cross over? Yes or no?
No, sir.
No, right? So that no interaction. But if there's no parallel, for example, look at this line, these two lines. Is these two lines are parallel?
No,
No.
sir.
Here it's not parallel. So that if the lines are not parallel, then we can say there's an interaction present. If they are parallel, no interaction presents. Right? So based on whether it is, based on how these are non-parallel, we can say whether the effect is, the interaction effect is very strong or very mild, or and so on. Right, I'm going to show you different diagrams of interactions. I'm taking only two factors. Let's say factor A. Factor A has two levels, 1 and 2. Factor B has again two levels, 1 and 2. Is it clear? So this is about 1 and 2 of factor A. This is B1 and B2 of factor B. Tell me the first case, whether do we have interaction or not? Anyone? This is on the y-axis response, right? Response mean could be the average yield. Tell me, is there an interaction? The first one. Nelu? Nelu? Nelu, kata karne aanawada, ahanawada? Nelum Ratnayaka. ඇහුන් නැත්තම් මං අහකට දානවා මං රිමූව් කරලා දානවා රිමූව් කරොත් ආයෙ එන්න බෑ ක්ලාස් එකට කතා කරන්න. If I remove you all from this link, then you cannot come back again to the class. I need the response. Maybe the response wrong, you are in the learning process, so you don't need to worry about. But you'll have to respond. Otherwise, I am teaching to some matto. Kaliman right? Kaliman, no response, no. Right? You'll have to have some kind of response. Right. Nelum, then katakan balu. Then what is the answer for the first one? Hello. Nelum Ratnayaka. Not the class again. Huh? Nelum Ratnayaka, not the class again. Right. Bhagya? Yes.
Yes.
Yes. Tell me for the case 1, can we find out whether interaction is significant? If you have problem in mic, you can answer in chat box. Yes or no? That is the question. Whether interaction is present in case 1. You can put it in the chat box. Yeah. So, no interaction. Yes. No interaction. So, we could say there's no interaction for case 1. There's no interaction for case 1. Similarly, look at the case 2. I mean, I'm talking about interaction. I'm talking about only the interaction. Huh? I'm talking about only the interaction. What about case 2? Anyone? You can put it in the chat. Case 2, yes, we have interaction, but it's called as mild interaction. It's called as mild interaction. Right? It's called as mild interaction. What about case number 3? Case number 3. It has some level of interaction where we call it as moderate interaction. That is called as moderate interaction. What about anyone? 4th one?
No any interactions.
No interaction. Right? 4th one is no interaction because we said they are parallel. These 2 lines are parallel. So you can simply, by closing your eyes, if they are parallel, you can say more or less parallel. Nah? Normally, in reality, we don't get parallel, but closer to parallel, then we can say no interaction. And when you cross very much, that is called as severe interaction. So it's perfect. Interaction is very perfect. So we call it in heart attack, we say mild attack, severe attack. You understand the intensity of the attack, isn't it? Mild mean very lightly. Severe mean very deeply. So similar kind of terms. Mild interaction, severe interaction, and moderate interactions. So these are the different interaction types. Now, if you look at, just tell me, in the case 1, how about factor A, factor B, and AB interaction? Tell me, how about factor A and B? What do you think about A and B? Anyone? What is the average of A? Average of A1 is there. Average of A2 is there. So there's a slope. So main effect A is present. What about main effect of B? Anyone? So we said no interaction. That is fine. What about B? What is the average of B? For example, average of B is there. Sometimes the average of B is there. Depend on how you are drawing. If there's a slope, for example, then B is also present as a minor. So these two are significant. Or the effects of A and B are present, but not B. AB. So likewise, as a homework, try all this. Draw in your real diagram and do it. So this may be slightly slant. You have to draw it very nicely. Even, for example, you have to draw it this very nicely, right? Because this is first level, this is the second level. So here you have to draw it nicely. It should be drawn like that. So here it's there's a bit of jumping here and there. So draw it correctly and find out whether all the effects are there. So interaction effect, as I said earlier in the last class, you simply calculate the value of this is minus minus, this is minus, plus minus, this is minus. Sorry, this is plus, this is minus, this is minus, this is again plus. So the average of 14 and 8 minus the average of 5 plus 3. So this is what we call as interaction effect. So you could see 8 is here, 3 is here. That is the value of x when x2 is plus. 5 and 14 are the values when x2 is minus. So take the average of these two and see whether the interaction is there. So that is how we find the interaction. Right? I have pointed out last time. So this is what we have already said. In a simple form, 2 to the power 2 algebra, you simply multiply minus into minus, which is plus, so that we get the ultimate values, so that we get the interaction effect of x1 and x2. Here we are considering x1 and x2, not the A and B. Right, so this is how interaction effect could be explained. We are not going to calculate in this form, but this is just for the explanation. Right? For example, you can write down now 2 to the power 3 experiments, higher order interactions. So when you talk about higher order interactions, let's say we have 3 factors, right? Factor A, factor B, factor C, right? I will just start up with one. So the interaction, two-way interaction AB, AC, and BC. Then ABC. You see? A, B, C, AB, AC, BC. So now we can say, can you remember, we have 2 levels, right? We have 2 levels where A, we have 0 and 1, or we could call it as A0, A1. Similarly, B, we have B0 and B1. C, we have C0 and C1. So that is the concept that we are using.
Sir.
Yeah.
Yes, sir. Neelam has sent message me that she had a phone problem, so that's why she could not answer. She conveyed that her message to you.
Okay, right. Because now I have already removed her, so that she cannot join now.
Yes.
So
Sir.
yeah. So ask her to join next time. Because I asked, because already whenever people are online, if you have problem listening, but chat does not have problem. Chat you can always accept it. So I always request everyone to reply through chat, at least if you can't listen. If you can't speak out from the mic, definitely you can put it in the chat. You have this problem, so this is the answer, then I don't deny anything on that, because I was repeatedly saying this several times, but she couldn't reply. So I cannot do anything now. Ask her to join in the next class.
Okay, sir.
So this is a warning to everyone. So at least if you are unable to listen, or if you are unable to speak out from your mic, definitely you can send a message through chat. Even if you can't, I mean, if you are not replying through chat mean, no one is sitting in the class. So people have just for attendance, you are switching on your phones or laptops, and you are doing your own work. You are not listening to the lectures, but later on you are asking for records and everything. So which I don't like. If I am giving the record, I have the records of last year taught to other students. I have several records. I can simply give the records. I don't want to come to my office during lockdown and teach you, right? So this is not I can upload in YouTube or whatever it is, then you can listen to the lectures. So if I have some commitment, you also should have your commitment. That is, send a message to Nelom that I cannot do now anything, because if I have removed once, I cannot accept. I think so. Ask her to log in. If she can log in, I can admit. Otherwise, I can. I don't know whether she is already logged on.
Yes, sir. She told that not permitted to log in.
Yeah, because
Okay.
I have removed her. Because if there is no response, எனக்கு தெரியாது அவள் சிலாக்கள் போட்டுட்டு போய் நித்திரையில் only கனவே பிடிபட்டிருக்கேன் அப்படி அதான் பிரச்சனை. அட்டெண்டன்ஸுக்காக போட்டுட்டு சிலாக்கள் தங்களோட வேலையே பார்ப்பின போய் போய் குளிப்பின போய் நித்திரை உள்ளவின எத்தனை வேலையை செய்யுது. அப்ப சரி வராது தானே அது.
Okay.
So tell her to join next time. Ask her, yeah, because normally in the Zoom it doesn't allow if somebody has already removed, it doesn't allow to come back again. That is a problem. So that is why I gave warning several times. So this is true for everyone. If I call your name, if you have problem unmuting, you can unmute the mic and you can speak. If you have problem in speaking, send a message through chat. Then I read it. After seeing the response only, I will decide whether this person is can be further continued for the class. Normally I don't do this, but this is you all are forcing me to do it. Yeah. So here, based on the positive and negative value, you have two combinations, A0, A1, B0, B1. How this could be written, for example, right? So look at this table. This table may be a little bit curious for you, but we can talk about that, right? Just you should know what is happening. So first I will talk about, let's say, I have two factors, 2 to the power 2, right? So we call it as A0, A1, B0, B1. Now, let's say A, B, main effects, AB. Right? A, B. So here, A0, B0. Right? A0, B0, A0, B1, A0, B, not, sorry, A1, B1, So this is how the combination goes. Right? This is how the combination goes. So here, when you talk about A naught and B naught, actually, I will take another, just a second. Right, how we decide this A and B, whether A and B are positive, A and B are negative. So you see here, the lower level is given as minus, the upper level is given as plus. The lower level given as minus, the upper level given as plus. Right? Lower level and the upper level in this case. So here, look at what is happening to A naught. A naught is represented by A naught. A naught is minus. Here minus, plus, plus. Is it clear to everyone? That is how it goes. That is how it goes. What about B? Here it is minus, plus, minus, and plus. AB is the multiplication of this. Multiplication of this. So what is the multiplication of this? A is minus, B is minus. So this is plus, minus, minus, plus. That is how it goes. Now, if you come to 3 factor, 2 to the power 3, A, you have A naught, A1. B, you have B naught, B1. C, you have C naught, C1. So we know that the values, this is minus, this is plus, this is minus, this is plus, this is minus, this is plus. Okay, this is minus, this is plus. So this is how it works. Now we can come up with A naught, B naught, C naught. What are the combination? Tell me. A naught, B naught, C naught. A naught, B naught, C1. A naught, B naught, sorry, B1, C naught. A naught, B1, C1. A1, B naught, C naught. A1, B naught, C1. A1, B1, C naught. A1, B1, C1. You see, all 8 combinations are there. You can see all the combinations. So this is the total number of combinations. So we have 8 combinations. So now we can find out what are the plus, minus for all these. So we know that A is represented by all the A components. So that here, minus, 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 plus, 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 plus. That is for A. Look at the how B component is. B component is minus, minus, plus, plus, minus, minus, plus, plus. Anybody have problem? Imasha? Ternada?
Yes, sir.
Terna. එතකොට කියන්න බලමු ඊළඟ එක කොහමද කියලා 100 එකට කොහොමද දාන්න පුළුවන්?
Minus,
Okay, because C naught is minus, yes.
plus,
Good,
minus,
good,
plus,
right.
minus,
Okay,
plus,
okay,
minus,
okay,
plus.
plus. Good, very good. Now let's go to AB. So AB, we cannot do it at present as we did. For AB, what we'll have to do, we'll have to multiply A with B and C. Right? You multiply the sign of A and B. right? Nishani,
Yes, sir.
yeah, tell me what is AB first.
Plus,
Plus, good.
plus,
Plus, good.
minus,
Right,
minus,
right.
minus,
Yeah,
minus,
yeah,
plus.
and plus, good. So you see, this is how the notations has been given. So you can find out for any AC, no problem, you can do it. For BC, you can do it, and ABC. For ABC, how do we calculate? Or how do we get the value? We multiply all three. If you multiply all three, it is for ABC. For example, that is minus. Right? Minus into minus is plus, plus into minus is minus. Right? What about second one? Minus into minus is plus, plus into plus is plus. Second one is plus. So likewise, to give the notation. Right? So everybody should know how to look at the notations, pluses and the minuses. Then only we can calculate, for example, the effects. Right? If I give the values here, for example, 8, 3, 4, 5, 9, 10, 12, 5. If I give the effects like this, now you can find out what are the pluses, what are the minuses. So you can take the averages and see whether these effects are there. Right? Okay. So this is nothing else. This table is as such. So here, according to our example, this is A, this is B, this is C. So this is AB, AC, BC, and ABC. Nothing else. So these are pluses and minuses. Now everybody should know how these pluses and minuses are. So this is applicable only 2 to the power n factorial. N mean it is the number of factors. 2 mean it is the number of levels. So 2 levels, high level and the lower level. That is the 2 levels that we are comparing. If you have 3 levels, we cannot have this concept. We'll have to have different concept. So we are not going to study about 3 levels in this signing, pluses and minuses. In the example, yes, we do with the 3 levels. Right, any questions from anyone? This is called as higher order interactions. So higher order interactions basically AB, AC, BC, ABC. All 3 interactions are called as higher order interactions. Right, further, I'm not going to talk about, I will give you the copy of this. I will upload it, a copy of this to the, what do you call your LMS, right? So you can find out the effects. If I want to find out the effect of, let's say in 3-factor also easily, you see, we can find out the effects. Let's say I'm going to find out the effect of X1. So you see what are the pluses and minuses there, take the averages and get the difference. So plus average, right? Take the plus average versus minus average. Similarly, if I want to find out the other effects, other main effects, we can do it. So this is pluses, all pluses, it is showing all the pluses of X1 and taking all the values. All right, so we don't want to, I'm going to skip this because, right, this is not necessary for you all to look into that, right? Right, any questions up to now? We are going to further. What is the model? Can you remember we talked about model? What is the model? What is the model? Anyone? So, what is the model?
Yij plus
Okay.
equal
Yeah.
mu plus
Okay.
alpha I
Mm. Here,
Eij.
yeah. Consider here CRD model. First, tell about CRD model. First, tell about CRD model. Anyone? What is the CRD model? Forget about the factorial concept. What is the CRD model? You'll have to tell now. Vijushan, what is the CRD model? What is the CRD model? Vidushan? Vidurshan. ஒராளும் உங்களுக்கு இன்டர்நெட் பிரச்சனை என்னென்ன எக்ஸாம் எழுத புரியல இன்டர்நெட் பிரச்சனை என்ன பாலசூரிய 1100 what is the CRD model
Yij equal mu plus alpha j
alpha j, right? Okay, whatever it is, plus
ij.
and කියන්නෝනේ
Eij.
yeah, error ij. So why you said j, Balasuri?
Yes, sir.
I ඔයා මෙතන j කියලා කිව්වේ මොන හේතුවද? සාමාන්‍යයෙන් අපි we use I here. The reason is here I is from 1 2 and up to t. T is the number of treatments. You can use j also, but right, j is 1 2 and goes up to r. What is that? Anyone? What is r?
Number of replicates.
Good. Number of replicates. So this is how this I and j has been defined. I and j has been defined. This is treatment, this is replicate. There is no any harm. This is correct. I mean, this is correct. Then you'll have to define these two other way around. So this is called as treatment effect. If we consider treatment effect as j, then we'll have to define the j as treatment effect, treatment, number of treatment. So we'll have to be careful, this I and j. Here, if you put j, then you'll have to define this j as j is from 1 up to t. I is from 1 up to r. depend on the definition. You have to be careful. Right, now I will use it, a simple one, the normal one, alpha I plus error term. So where I is from 1 up to T, it is the number of treatment. J is from 1 up to R, number of replicate. Right? So this is the normal CRD model. Now, here, this is going to be expanded. This is going to be expanded. So our simple two-factor model, I'm going to say Yijk is equal, right, mu plus, I will use different terms, AI, right, plus Bj plus ABIJ plus the error term. So this is how it goes. So here, so this alpha I is including these components. What is alpha I here? In the first case, what is the alpha I? Anyone? How do we call this alpha I? What effect?
Treatment.
Treatment effect. Fine. So this treatment effect going to split into these component effects. So this component is due to our, how many factors are there? How many factors are there? In this example, 2 factors. So this going to represent the factor A. This going to represent factor B. What about this? Anyone?
A and B.
Good. That is going to represent our AB interaction. So this is the expansion of the treatment effect. So everybody should know this is the expansion. Actually, this alpha I is the, if you add these 3, it should be equal to alpha I. That is the concept. Right? Now, if you know the concept, you can write it very easily. I'm going to erase this. Right? I'm going to erase. Now, I'm going to go with the, now you see, two-factor CRD model. Two-factor CRD model. This is how it gives. So can you remember earlier I said we can take these 3 as treatment effect. We can give any notations. Don't worry about any notations. So this is the treatment effect. This is replying. This is responsible for factor A. This is responsible for factor B. This is responsible for the interaction of AB. And this is the random effect. Right. So this is the simplest model for a CRD. You can write down. I don't know whether, yes, it has been given. I is from 1 to A. So this is the level of factor. For example, factor A, we say 1, 2, we don't know how many levels, 3. So likewise, A. Similarly, factor B, starting from 1, 2, goes up to B. So that is what here it has been given. So I indicating, the digit I indicating factor A, digit J indicating factor B, digit K indicating now our replicate. So we'll have to have replicate also, right? You'll have to have replicate. For example, A naught, P naught. A1, A naught, B1, A1, B naught, A1, B1. So these are the 4 treatment combinations in our early example. So this has to be replicated. This has to be replicated. Then only we can do the experiment. Can you remember? We said what are the benefit of replicates and so on. All right. So that is the advantage. So here, these are the treatment combinations. This is one set of treatment. So it has to be replicated. Right? Right. Any questions up to now? So we'll have to write down the model very carefully. Now we will write down the name of each component. How we can write this Yij? Anyone? Peony? කොහොමද ලියන්න පුළුවන්? Yeah. ඔයගොල්ලෝ කලින් ලියලා ඇති. බලන්න. So this is referring levels of factor A, levels of factor B. This is the replicate. Tell me Yijk. How we can write Yijk? I will use difficult to write it here. I will use the other. So Yijk is equal mu plus alpha I plus beta j plus alpha beta ij plus the error term. So this is what I have already given. So Yij k, how can we write? Observed value of ith level of factor. Which factor? I is referring to which factor? Factor A or factor B? We already said A. So we can say observe value of ith level of factor A. What about ith level of factor A and jth level of factor B in kth replicate? This is how we write. Observe value. Observe value. Now tell me Y1, 2, 1. How do you define this observe value?
Observed value of one's level of factor 2 and first level of factor.
I can product pattern. You can tell once again. Observe value of, start from here, that is easy. Start from this direction, that is easy. Observe value of first level
Observed value of
first level of factor A and
second level of factor B in first replicate.
Good. So that is how you explain this, right? So because we have experiments, right? We have experiments, so that Y211, Y222, for example, Y121, Y122. So we should be able to explain this. Right. Now, I hope everybody is writing down this. These are not in the notes, so that I hope everyone is writing down. Huh? Right. Now, tell me, what is this second compound? This is not new to you. Everybody is familiar with this.
Grant me.
Okay, grand mean. So that means this grand mean, or it's sometimes called as overall mean. Right? Right. The third component, alpha I. What is that? Anyone? Now, I is not treatment. I is factor 1, referring factor 1. Right. Yes?
Effect of factor. Mhm.
Effect of
Factor 1 effect.
okay. Factor 1. We cannot. We said not factor 1. Can you remember? We said we have given. Can you remember? I is from 1 up to A. J is from 1 to up to B. K is from 1 up to R. So now we cannot say factor 1. We have given the name.
Effect of factor B.
Factor A, right. So it is called as, what effect that? Can you remember? We talked about different types of effects now. We said the main effect, we said the interaction. Which effect is that?
Main effect of it.
We can say main effect of, because you remember I discussed about main effects and the interaction. So main effect of, right? Main effect of, right, factor A. Right? So that is reflecting the main effect of factor A. So if you say, for example, alpha 1, right? We could say, right? If you want to say in a better form, ith level of main effect of factor, if you want to tell more precisely. Even main effect of factor A is fine. Right. What about this one? Now tell me, somebody, how we can write that. Anyone?
Jth level of main effect of factor B.
Right. So it is called as, it can be called as main effect of factor B. Or we can say jth level of factor B. Right. Now alpha, beta, ij. Anyone? Interaction effect of ith level of factor A and jth level of factor B. So if you have defined factor A and B, then you can run without any problem. If any have any problem, you can ask. The last one, EIJK, it is the random effect. Random effect, or we call it as random error. That is also right. Random effect of ith level of factor A.
Excuse me, sir.
Yeah.
Random level or residual level, sir?
Random, we call it as several names are there. Random effects, residual effect, right? Then residual or error, all these are same. You can use any name. All are synonyms. Huh? You can use any of those. Random effect, residual effect, residual error, all these are same. You can use any of those, right? Random effect of ith level of factor A in jth level of, write down, level of factor B in kth replicate. Kth replicate. Right. So every maybe I don't know whether you have learned this. You have written the model in your CRD, RCBD. So all these effects, I think you could have written very carefully. For example, in RCBD, CRD, you have done this. Vidushan, RCBD, CRD ki model alipotto இது எக்ஸ்பிளைன் பண்ணீங்களா ஒரு காம்பவுண்ட்? எஸ் சார். Sudharshan,
Yes, sir.
RCBD CRD కి మోడల్ అడిగిపోతూ ఇప్పుడు వివరించనింగళా ఓవర్ కాంపౌండ్?
Sir.
Right, similar to that, right? So here we write down each component separately. Right, this is in a CRD model. If it is in CRD, no blocks involved. Replicates are involved, but no blocks. Right? So, right, I'm going to go for the ANOVA table. Right? Let's look at the ANOVA table. Right? ANOVA table, I don't know whether, yes. First one, because can you remember in the CRD, complete randomized design, we said this component is due to treatment. This component is due to error. Now, if you say 2 factorial in CRD, right? Now I am saying 2 factorial in CRD. Now what is happening is, right? Actually, this treatment component divided into different components. One component we say it is due to factor A. The other component, I will just mark it in red color. The other component, we call it as it is due to B. The third component is due to A. This is actually happened by principle. By principle, this is what happened. Okay. By principle, this is what happened. So that we could expand this, because can you remember we said already, so this the whole setup here, the treatment is partitioned into different compounds. So right, treatment is partitioned into different components. So you see treatment actually partitioned into, if it is a two factor, A component, B component, and AB component. Then we have the rest. In CRD, look at it. In CRD, we have treatment, error, and the total. So here, this is actually belongs to this component. It has been expanded. So that is the concept. Right, total. Now we will come to the degrees of freedom. In CR, the degrees of freedom, we say T minus, sorry. In CRD, we say the degrees of freedom is, go back and see T minus 1. In CRD, T minus 1. Go back and look at your notes, CRD notes, T minus 1. So this T is now comprised of two components, AB. So that we can write it as AB minus 1. Tell me, how about the total degrees of freedom, anyone? You should understand the principle. Total degrees of freedom, assuming that all of them are having same replicate. In CRD, what is the formula for total degrees of freedom? Anyone? Look at your notes.
TR minus 1.
Okay, TR minus 1. Now tell me, what is the present degrees of freedom? R is already there. Instead of T, what is the degrees of freedom? Instead of T, what we can write?
AB.
AB. So now we can write it AB R minus 1 in simple form. What is how many levels are there in A? Factor A has total of A number of levels, so A minus 1. How many levels of factor B? B. So that B minus 1. So this is A minus 1 into B minus 1. This is AB into R minus 1. This is how the same thing, because in CRD you might have taken this as T. So I'm going to write down all of them. There is chat, yes, good. Right. I will write down the degrees of freedom. So everybody should understand what is the meaning of how these degrees of freedom are coming. How many independent levels in A minus 1, independent levels of B minus 1, independent levels of AB, that is A minus 1 into B minus 1. Total minus rest will be the degrees of freedom for error. So you will end up with this. So always you end up with here, it is same as CRD. So here, this is T, this is T, this is T. Look at it, see, in CRD, all are same. If you add these degrees of freedom, it should be equal to this. If you add all these, it should be equal to this. Statistically, mathematically, you add, for example, A plus, sorry, you, as a homework, you can try A minus 1 plus B minus 1 plus A minus 1 into B minus 1. This will be equal to AB minus 1. You go home and try this. Right? So here, It's like that. Is it clear? Right. Now we will come to the notations. We know I is given for 1 to A. J is given for 1 to B. K is given for 1 to R, replicate. Right? Here, for example, Y 1 1 1. So it is the first level of A, first level of B, and first replicate. When I say, right, you have already learned these notations, right? I think you have already learned these notations. That is important at the beginning. So hopefully, I think I have seen these notations. So the treatment effect is given as such. Summation Yij, because Ij, it is including A and B. That is the treatment effect. Dot square divided by R. Minus, this is called as correction factor. Correction factor. Have you seen this kind of correction factor in earlier CRD RCBD? Yes. Right? So we could have the formula like this. When we do this example, we will see. Then this is the effect of correction factor, always it comes. So the effect of, for the time being, write down this. Effect of A is given as summation of B, sorry, summation of Yi dot square divided by Bn. This dividing factor is depend on how many components that we are adding together. So here we have adding only one across one component of replicate. We add all the replicates, so that we are dividing by R. Here we are adding all the components across the replicate as well as the factor B, so that we are dividing by BR. Right? Okay. Then the third one, sorry, factor B is given as such. Factor B is given as such. Write down that. We will do an example, in-class example. Then the interaction effect is coming basically from treatment minus A minus B is given as interaction effect. Total effect, we write it as such. Summation of Yijk square, then minus the correction factor. The mean squares are as usual, you know, you get the mean square, that is sums of square divided by the degrees of freedom. So that is the principle in all the aspects. Right. Now I'm going to put up a question. Have you all taken down this? We'll take a simple example. I will see. Everyone should have the calculator so that we will looking for a CRD example. Right. This may be not related to agriculture, but we will do an agriculture related example also later on. right? So this is something to do with a computer, right? Computer. I will give the stem of the write down this. Right. The question is, we have two factors. Factor A is multi-programming. Factor A is multi-programming. I will come to the data. A is multi-programming. B is memory. Actually, these are something to do with computer program. For example, when you use computer, there are different computers with different memory size. So usually what is the situation? If the memory increases, the number of multiple programming is in generally high, isn't it? So we want to have whether there's an interaction between the number of multi-programming. For example, this is multi-programming, only one program, two programs, three programs, four programs, and so on. So it is called as multi-program. So how this relationship is between the multi-programming and the memory size of the computer. So output, the results, is based on output. We are measuring how much time it has taken in seconds to give the output. You are applying, for example, SAS or SPSS, you are running the program. So what is the time period that it took to give the output? So that is the question, basically. So now I'm going to give you the data. 0.25, the output taken time period, 28052, write down this, 048, 081, 076, 1.50, 1.61, 0.21, 0.19, 0.45, 0.49, 0.66, 0.59, 1.45, 1.32, 0.15, 0.11, 0.36, 0.30, 0.50, 0.61, 0.70, 0.68. So these are the data. These are the data. Right? Now tell me, for example, this first data, I can write it as Y111. Considering the first is the level of factor A, second is the level of factor B, third is the replicate. Can somebody tell me how I can write this? How can I write that in a notation? I'll get a glass of water. How we can write that? Anyone? Just try, no problem. This is indicating factor A. This is indicating factor B. This is indicating replicate. How can I write like that? That one. Why? Anyone?
Y132.
Good. 1. It is the first level of A. 3. It is the third level. This is first level, second level, third level of B. And under the third level and the first level and the third level of A and B, we have two observations. This is first observation, this is second observation. So that we could write it as, 132. Right. Now, can you work it out? Can we complete the ANOVA table? Can we try with the ANOVA table? Can you calculate all these effects? Treatment effect, main effects of A, main effect of B, interaction, total effect, and the other total effect and the error component. We will find out all these values. We will have, you can continue. I will start, come in a couple of minutes. Yeah, I will give you 2 minutes. You can try. Then we can try together. Do you want to do it as a homework or Sanush Kumar? Will
Yes,
it
sir.
take homework? We can discuss the answer, but
The homework, how is it?
Because everybody should definitely you will get the questions like this in the examination. So you have to try this. So this is actually 2-factor factorial in CRD. This is actually 2-factor factorial in CRD. Right? Yes, you can try this as a homework. We can do it next time, right? In the next class, we will look at this. But I will ask the question from everyone. Everybody get ready. The second reason is, I mean, if you have any problem in calculation, you'll have to tell me. For example, we said summation of y I j dot square divided by r minus correction factor. Correction factor is actually y dot square divided by abr. Right? Correction factor is actually, if you add the total of these, let's say it is x. If you add the total of x, so this is x square divided by how many levels in A, how many levels in B, how many replicates. What is A, B, R? Anyone in this example? Peony? What is the level of A? What is the level of A?
4 levels.
Huh? 4 levels. Yeah, good. What is the level of B? Anyone?
3 levels.
3 level. What is the level of B? 3 level. Yes, good. What is the level of R or the replicate?
Two replicate.
2 replicate. Yes, good. A, B, C. Yes. A is actually 4. P is 3. R is 2. So here you'll have to divide by 4 into 3 into 2. So that you'll have to calculate, right? So that is the correction factor. How do you get this effect? I, J effects. Anyone? So that means we'll have to add all these values. For example, this is called as treatment.
Sir, excuse me, sir.
Also square. Yes.
Can you please explain one equation for?
Pardon?
Can you please explain this question for?
Question.
No, sir. I want this question for answer, sir, because
Answer. I am giving the guideline. We will discuss the answer. You'll have to calculate, and we will discuss the answer in the next class, because it take at least half an hour to find out the answer. I mean, at least 20, 30 minutes. So I will give the guideline to get the answer, right? So treatment, because you have expert on calculating CRD, RCBD, right? So because if you start with that only, you can continue with this. That is the importance. Now you should be able to do it very quickly, right? Anyhow, I will explain this. So this says, for example, y11 dot plus y12 dot, right? Square all these, huh? Plus y13 dot, okay? Plus y21 dot square plus y22 dot square. So this is the principle.
home sir konjam கஷ்டமா தான் இருக்கு போல
CRD ஒழுங்கா செய்திருந்தீங்கன்னா இதுவும் செய்யும். இந்த நொட்டேஷன் இது நொட்டேஷன்ல வரும். அப்ப ஆரம்பத்துல வடிவா செய்திருந்தா தான் இது தொடர்ந்து செய்யலாம். இது நான் புதுசா படிப்பிக்க இல்லை. இது CRD ஒழுங்கா செய்திருந்தோம் அந்த பிரின்சிபல். எஸ், பிரின்சிபல் விளங்கணுமே, அடிப்படை விளங்கணுமே. எல்லாரும் சும்மா கணக்கு கூட்டி கழிச்சு போடுறதுல ஒரு அர்த்தமும் இல்லை. ரைட், நான் விளங்கப்படுத்துறேன். Yeah, I will explain. So this I am expanding here. I am expanding this. Don't worry, I am expanding the principle. Y 21, 22, 23 dot square. Right? Now tell me, what is this? Because we haven't completed this. Still some more to go. What do you mean by 111 dot square? Can somebody tell me? Tanish Kumar Silungu.
சார் எனக்கு தெரியும்.
இல்லை இது என்னன்னு சொல்லலாம். இதை 1 இது ஒன் இதை விளங்கப்படுத்தினீங்களோ அதே மாதிரி இதை விளங்கப்படுத்தும். முதலாவது
first A effect.
Which A effect? First level of A effect.
A effect and the first level of B effect. In first level of B effect.
Right. So first level of A effect, first level of B effect. Add all the values of first effect of A, first level of A effect and first level of B effect. Add all the values. So what is that? For example, in our example, what is that? Add all the values in the first level of A effect and first level of B effect. What is that value?
0.25.
Yeah, you will have to tell. I mean, before adding, you will have to tell what are the values you are adding. Everybody knows. What are the values we are adding? We are adding
0.25 plus
value 0.25 plus
0.28.
That is the value. Right? So now this is actually, what is the value? Now you tell the added value 0.53. இப்போ நீங்க கால்குலேட் பண்ணி சொல்லணும். நான் என்னடா எனக்கு மேல கீழே போயலாம், நான் மறந்துடுவேன் டக்குன்னு நம்பர்ஸ். Is that correct?
Yes sir.
Now you see, when you see the dot here, we are adding across the replicate. So square it. So you square it. So this is the answer for the first one. Let me answer for the second one. Anyone? Answer for the second one. Yeah,
0.40 all to the power square.
40. Yes. Tell me, what are the values you added?
0.21 plus 0.1.
Exactly. So now you see, we are adding the values of the first level of A plus the second level of B. That is why we are saying y1, 2 square. So that answer is 0.40 square. Is it clear to everyone how we are getting this value? Right. I didn't stop this calculation. I started with that. 1 dot square, 1 2 dot square. Can you tell me what is next here? Y. You have to calculate for all the levels of A and B, all the combination.
3 1.
Good. 3 1 dot square
3 2 dots.
plus 3 y 3 2 dot square plus
4 1 dots. 3 3. 3 3, sir.
3 3.
Yes, sir. 3 3 dots.
3 3. Okay.
Plus 4 1 dot square.
4 1 dot square. So likewise, you complete up to, what is the last one?
4 3 dots.
4 3 dot square. Right. We didn't complete yet. Right. Right. You can add all divided by R. What is R?
Number of rep.
How many replicates do we have in our case?
12.
2. Right? Number of replicate is 2. That is why we are dividing. Minus our correction factor. I will put it as C. No problem in calculating correction factor, isn't it? Correction factor is simply you add the value here. I have shown you. You see, add the value there as a x, it is square. You add the total value. You'll have to add all the total value, square, divide by. So you can keep this as a correction factor aside. Always you can take this as a correction factor. Anybody has a problem calculating this? You have to calculate individually. This is called as treatment sums of square. Right. Now I will show you sums of square due to A. Right? Because in the ANOVA table, we'll have to fill all these components. Sums of square due to A. So what is the sums of square due to A? What is the formula? Look at your formula. Everybody should have written the formula when I showed you in the PowerPoint. What is the formula? Can somebody tell me? Summation. Anyone?
yi dot squared over br minus
PR minus C. Correct? Right? Everybody got it? Rizvia, got it?
so y square and the over individual value மொத்தமா கூட்டி அதோட ஸ்கொயர் தான் y square. y dot dot dot
y square and இல்லையே இதுல சொல்லுங்க.
y dot 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 square.
And மொத்தம் total grand total. You add all the values and square it.
Okay. Sir, இங்க இந்த இப்ப
And நீங்கள் CRE ல படிச்சிருப்பீங்க correction factor. You should understand the principle, then only you can apply. Chalo, Jayakumar. Tanush Kumar. Yes, Tanush Kumar.
Sir, miss படிவா படிப்பிச்சவாதான் கொஞ்சம் எனக்கு அண்டர்ஸ்டாண்ட் பண்ண முடியாம.
உங்களுக்கு தனியாவா எல்லாருக்குமா? இல்ல if you need I can clarify, no problem. I can explain. உங்களுக்கு விளங்க இல்லைன்னா கேட்கணும். எல்லாரும் விளங்க படிக்கிறது தானே. මුලංගම පටිච්චරදල අර්ථම් இல்லையே. හැම එකනම ඉගෙන ගන්න තමුන්ට තේරෙන්න විදියට. තේරුම් කරගන්න තමයි අපි ඉගෙන ගන්න. නැත්තම් ඉගෙන ගන්න අවශ්‍ය නැහැනේ. ඒකට තමයි අපි ඉන්නේ. අපි උගන්වන්න තමයි අපි ඉන්නේ. Right?
Sir, நானேக்கன் பெரும்பாலான ஆட்களுக்கு பிரச்சனையா தான் இருக்கும். பட் அவையெல்லாம் சொல்லணும் சார்.
Yeah. Everybody should answer what is your problem. First, I will discuss about this. If you have problem in CRD, then I will discuss about CRD calculation later. We should combine these two together now because we have started with this too. Right. I will, everybody, I mean, I need the response so that then only I can continue. All right. So now tell me, this is the sum square of A. Because can you remember in the source of variance, we have all these sums of square, source of variance, we have all these components. Treatment, A, B, AB, error, and total. Everything we'll have to calculate. So we have calculated the first component here. I gave the guideline to calculate the first component, treatment sums of square. All right? Right. Now, sums of square due to A, we can calculate. This is actually y1 dot square plus y. Anyone? 2 dot square plus y3 dot square plus y4 dot square. Why I say, what is y1 dot? What it refers?
It refers, sir, I think, only multiplying that value.
Which value? No, first look at the digits, subscripts. Look at the subscripts, then only we understand. Here the subscript says y1 dot before squaring. What is this? So, for example, look at here, y1, 1. So this is factor A, right? This is, yeah, A matram, but you'll have to tell precisely.
Adding all the factor 1.
All the observation on factor 1. Okay. Now tell me, so how many levels do we have in factor A?
4 levels.
4 levels. So that is why I have given here up to 4, because I didn't go beyond that. So this is actually total square of first level of factor A. Is it clear? So you add all the values belongs to first level of factor A, right? So what is the first level of factor A? Total value. First tell me what are the observations that you are going to add.
0.25 plus 0.28.
Is that only belongs to first level of factor A?
0.25 plus 0.28, sir.
0.25 to
First level
1.6.
then
So we'll have to add, because this is the category of that we are going to add. So under that category, how many observations are there?
6, sir.
You'll have to add all these observations across all this. So because that is because we said y1 dot. So we'll have to add, this is, if you add all this, it is giving us y1 dot. If you add the second group, it is giving y2 dot. Before squaring, squaring is secondary. That is not. Then third one, y3 dot dot, and this is y4 dot dot. Is that all clear?
Yes.
Right.
Yes, sir.
Now look at this carefully. We are squaring this. Before squaring, how many observations that we are adding? In each cases, how many observations that we are adding? Huh?
Six observations.
6 observations that we are adding. Right? We are taking the average. We are dividing by 6. How this 6 comes? How we can explain this 6? Anyone? It is the level of B and the level of replicate. Multiply these two. Hello? Can you hear?
Yes.
Okay.
Sir.
Multiply this B and R. What is the value?
6.
So because across the BR, the constant is only the first level of factor A. Across the BR, we are adding all the values. So before we square, how many observations that has been added? It is actually equal to BR. That is why we are dividing by, before squaring, we are dividing by BR. So before we square it, how many observations that we are adding? So that is based on B and R here. Similarly, in this case, when you calculate the sums of square of treatment, how many observations we are adding before squaring? How many
6.
observations? Huh? In early case, treatment sums of square.
2.
Early. 2. What is that 2? It is equal to replicate. So that is how this division factor comes, not magic numbers. These are with some reasonable, taking the average, right? Before squaring, what is the number of observation that you are adding? It is coming as the dividing factor. So that is the principle. Is it clear? Now you can calculate this sums of square of A. You can calculate. Any problem with sums of square of A to anyone? I showed you the guideline. Now you can calculate the sums of square of B. What is the formula? Tanush Kumar Sariyal.
Holmes,
Right. Tell me now. So this is actually y dot 1 dot square plus here I will have to give this divide by BR. Huh? So we'll have to add that also, divide by BR, because you cannot leave it as it is. Then minus the correction factor. You'll have to write that, otherwise it is incomplete. Right, now the sums of square due to B. Tell me, this is y dot 2 dot square plus how many levels are there in the
3 levels.
3 levels?
Each level have 8 digits.
Okay, so divided by C, divided by AR. So now tell me, for example, is it okay? This is how it has been written. Minus C here. Right, I'm going up to show you. Now, what is this? How we can explain that? It is the total square of what? first level of factor B. So now we are adding the value first level of factor B. What is the first level of factor B? First level of factor B is that. So we are adding across this. So this is actually y dot 1 dot. This is, if you add this, how many digits are there? 8 digits, right? If you add that, it is y dot 2 dot. If you add this, y dot 3 dot. Is it clear to everyone? Omo illio, Tanush Kumar?
sir. No.
உங்களுக்கு இப்ப கிளாஸ் இருக்கா? எனக்கண்டா 10:30க்கு ஒரு மீட்டிங் ஒன்று இருக்கு. இன்னொரு 5-10 நிமிஷத்துல முடிச்சுக்கோங்க. Right. Right. So this is how this works. So you add. So how many observation you added? 8 observation. So how this 8 observation comes across, right? So you see, this is 4 levels in A. This is 2. So that 4 into 2 is 8. That is how it comes. Correction factor always same. Huh? Don't change this. Sorry. Is it clear? Now, if you go to sums of square of AB, how do we calculate? Sums of square of treatment minus sums of square of A minus sums of square of B. Look at the formula. Go and look at the formula. It's there in the ANOVA table. Am I right? Then the sums of square of total is calculated as y111 square plus y112 square plus y. So before giving the formula, I just before giving the explanation, I give the formula summation y(i)j(k) square minus c. So this is the formula you could have seen. So that is equal y111 square plus y112 square plus y121 square plus likewise. It goes up to the last component. Last component in our case is y432 is the last component. Because each of these components has been, that is why at the beginning I asked you to name each of these components, right? So each of these components, this is y11, already we have given. Similarly, this component is y132. So likewise, the last component here, it is given as y432. Am I right? Yashani, am I right?
Yes, sir.
So you don't need to say always yes, because I may be wrong sometimes. You have to critically think and say, right. So you can calculate, you get all the values and square it, right? All the values and square it minus correction factor, You get the values, first value is 0.25 square. Can you remember in the example? Plus the second value is 0.28 square, plus goes up to the last point. I couldn't remember the last point, yeah. Minus correction factor. This is the total sums of square. Once you get the total sums of square, right? Once you get the total sums of square, the sums of square of error is calculated by total minus if you go total minus all these components, rest, I will say rest. Rest mean all these 8 components. I mean, not 8, for example, I will show you. Total minus rest. Actually, total minus rest mean here we'll use, right? Here total mean this component, right? This is actually total. Minus rest mean either you can take these 3 or this 3 is same as this 3. You calculate and see the value. You will get, let's say, if this is the value is x, the total of this value also will be x in the sum square, right? Total value of this also called as x, definitely. So you can here total minus, here this is total minus treatment sum square, or total minus sum square due to A, sum square due to B, and sum square due to AB. This is same. This so that you cannot use the both. You'll have to use only one. Rest mean only this or that. Because as you all know, the sum square AB and AB, A, B, and AB, altogether it is same as treatment sum square. So that again, we cannot deduct twice the treatment sum square. So, echo api treatment sum square, total sum square, hinkala error hoyanone natta AB saha AB interaction vali subtract kala ganna. Nangal undu total sum square and treatment sum square kalikradala error sum square varala. Alladu total sum square and A sum square, B sum square, AB sum square kalikradala error sum square varala. Rendu tharam kalikirunda. So I said this or this. Right, we will see that in the next class. Everybody should calculate the values. At least you'll have to calculate all the sums. You calculate in with the detail, as I pointed out here, so that I will ask the question from everyone. Sorry. I will ask the question from everyone from what is this component, what is this component, every component. Get ready for everyone. Any questions? I can entertain 1 or 2 questions. Yeah. Any questions? I have a meeting at 10:30. Otherwise, I could have continued. Yeah. Tanush Kumar, Blangja.
Sir. Sir, இந்த factor ரெண்டு சொல்றீங்களோ இந்த A factor B factorல இப்ப 4 levels A ல B ல 3டா நாங்கள் எடுக்கிறப்ப எந்த இதை டெஸ்ட் பண்ண போறோமோ அதுல 4 வெரைட்டிஸ். இப்ப கன்சன்ட்ரேஷனை மாத்தினா அது A இந்த கன்சன்ட்ரேஷனை மாத்தி 4, B என்பது வேற ஒரு டாபிக், அதுல 3 வகையா செய்யலாம். ரெப்ளிகேஷன்ல ஒவ்வொன்றையும் 2 சாம்பிள்ஸ்ல டெஸ்ட் பண்ணணும். அப்படி
இல்ல in this example, let's say here we have factor A. Factor A has 4 levels. Let's say A1, A2, A3, A4. In this example, factor B, it is the memory of the computer, B1, B2, B3, 3 levels. Now we have the combination of A1, B1, A1, B2. Now this is one treatment combination. We need to replicate this. That is why we have the replication. Without replication, we cannot calculate the error term. No? So that is why we are replicating. So it has been replicated twice, right? 2 times. So here A level, 4 A levels, 3 B levels, and 2 replicates. Did you understand? So here we could say, I can take another example. Maybe I will talk about another example later. Let's say factor A, factor B, I have variety, PG 350, right? BG 352, 2 varieties. Broadleafs, weeding. Tell me, broadleaf weed killers, weedicide. I don't know, I couldn't remember because I'm not teaching weedicide. No. Anyone? And the weedicide, broadleaf weedicide. 40 വർഷത്തിന് മുതൽ പഠിച്ചത് ഞാൻ ഇപ്പൊ ഞാൻ MCPA
24 DCP
24
DCP
right DCP right
so DCP.
Okay, so you see this is a situation, right? We are testing with 2 varieties to we decide. Maybe we can increase the number of varieties and number of we decide, that is up to us. But as an example, we can increase 4 variety, 5 variety, and so on. So this is a real situation, real application, right? Now let's say I'm going to germination test. I have tomato. Tell me some variety, 3 variety. Tilina, Maglo. Give me one more variety.
Roma.
D R Roma.
R.
Right. Okay. So I have some germination test, right, for different varieties. I have let's say germination hormones in the market. Hormone in the market. I don't know, Rootone or whatever it is. Rootone. Some, let's say another one and another one. 3 available in the market. I want to see sometimes for some variety of tomato, Rootone may be best. Maybe, I don't know. Maybe Maglo, hormone 2 may be showing much higher germination percentage. So this is what we call as interaction. So we want to find out. This is a typical practical situation. I mean, we can do a lot of work in agriculture using this. So I gave a very sense of that, flesh of that, but you can apply in different forms. Even in the field, you can apply. Right? Right, I think I will stop with that. We can continue if you want next time.
Thank you, sir.
Okay, right. See you all. The other thing is coming Friday 8 to 10. Huh? The next lecture will be coming Friday 8 to 10. Right? So yeah.
9 to 11 உங்களுக்கு பிரச்சனையா இருக்குமா சார்?
எனக்கு பிரச்சனை இல்லை. 10க்கு அப்புறம் உங்களோட அந்த சிக்னல் பிரச்சனை இல்லை. அதான் அதுக்கு தான் என்ன பிரச்சனை?
ஏன்னா சார் ஒரு டிபார்ட்மெண்ட் ஏற்கனவே இதாண்டுட்டு நாம 8 தொடக்கம் 9 அப்ப கேட்டு பார்க்க அவையில கேட்க சொன்னான்
என்ன டிபார்ட்மெண்ட்?
எக்கனாமிக்ஸ் டிபார்ட்மெண்ட் ஏற்கனவே அதை போட்டிருக்காங்க கிளாஸ்.
ரைட் ரைட். சூரி சார் எந்த சார் தெரியா?
இங்க எக்கனாமிக்ஸ் டிபார்ட்மெண்ட் சொல்லுங்க இந்த சார். ஹலோ.
Uma Shankar sir.
Right. Okay, so that is finishing at 9 o'clock.
8 to 9:30.
9:30.
சார் அப்ப
Maybe
பிரச்சனை இல்ல
9:30.
சார். அவியல் அட்ஜஸ்ட் பண்ணிட்டு நீங்க 8 to 10 எடுங்க சார்.
இல்ல எனக்கு 9க்கு வரலாம், பிரச்சனை இல்ல. Is it okay if I start at 9? I can start at 10, but the only problem is you all will have problem in internet. That is the problem. I don't have any problem. Latest 9 would be. What is the signal problem? I don't understand. 1076. What is the signal problem? You'll have to tell the time where the signal problem. What time is the signal? Because I'll have to finish the syllabus, huh? என்ன செய்வோம்?
சார் நீங்க 9 to 11 போடுங்க சார். அவியல் ஒரு half an hour அட்ஜஸ்ட்.
half an hourல வரட்டும். எனக்கு எல்லாம் செய்யலாம் தானே. So we will start at 9, huh? On Friday. Yeah. Okay. Okay.
Thank you, sir. Thank you, sir.
Okay, bye.